Where? On the top or the bottom? Okay, so again, right now we are applying the magnitude of the stress equal to simply is my over I. In this calculation, I don't take any sign. Okay, I don't take any sign. We're simply looking into the magnitude. So the maximum of the material will be up or the bottom here. So that would be at top or at bottom, and as indicated here or here. So that one, the stress will be equal to on the transformed. Here the T indicated is on the transformed, will be equal to the magnitude of stress. Okay, here I highlight the magnitude. So here the bending and times the distance. The distance here is how much? 30, right? 30 millimeter. And divide by I. We save the space. I is there. How about this? 666.67. I leave the unit conversion for you, but I just write it down. And on the original cross section, sigma 1 basically equal to M1 times sigma 1 on the transformed cross section. And here is the way, here is our final step. We simply interpret the result on the transformed cross section, which is based upon this our formula. We transform that, we interpret that result by making this one, and let me highlight making this one. Okay? And the same thing on the two material, that will be equal to My, N times the maximum stress in material 2 will be where? Will be here, right? Either this side or this side, as I highlighted. That is the place that farthest away, the most distance from the neutral axis. And how much is that distance? 20 millimeter, right? And again, 66667 times 10 to the minus 9. Okay, and now we get back to the original, then the stress in material 2 will be equal to N2 okay. And then for our situations, we require is this number must be less than or equal to our allowable, that is 100 MPa. And this one must be less than or allowable to the 160 MPa. So from these equations, you'll be able to calculate M is less than or equal to a number. Here is 2.22 kilonewton per meter. And from this equation, then you can find the M is lower than or equal to 3.56 kilonewton per meter. So here we have two numbers, and we have to, you can see, I prefer is I use the less or equal sign, because that to the final step that can clearly tell me which number I should go forward. Okay, so that means here we can see M should be less than or equal to 2.22 kilonewton per meter. So we pick is this number. Okay, and sometimes if you using the equal sign and to the final, you have to think a little bit carefully to pick one number correctly. But here, if you use the range of the domain, then that will be helpful. So this is for the composite, and on the slides, there's one more example, and then on the the handouts I post on Blackboard, there's more examples of the two material you can take a look at to practice yourself. And on the homework, and I haven't finished that yet, but on the homework, the material I proposing is this one.